5.2 Relevant Formulas and Constants. Ohm's law key ideas are that Ohm's law states that the voltage across an electrical component is equal to the current flowing through it multiplied by its resistance. In practical terms, if you know the voltage and resistance, you can determine how much current will flow, and if you know the voltage and current, you can find the resistance of the component. Related electrical concepts are that electrical power describes how much energy is being used each second, and it increases when either the voltage or the current increases. Power can also be understood in terms of how strongly the current pushes through resistance. The resistance of a wire depends on the material it's made of, along with its length and thickness. Longer wires create more resistance, while thicker wires reduce it. Different materials also affect electrical flow. For example, copper allows electricity to move easily because it has low resistance, while materials like nichrome or carbon resist the flow more strongly. Some helpful reference facts are that common electrical references include the fact that metals such as copper have naturally low resistance, whereas some alloys and nonmetals have much higher resistance. Electrical measurements often use prefixes such as milli for very small currents and kilo or mega for larger resistances.
The benefit from knowing this problem is it is the most basic rule of electricity, and it is important to understand if you're going to work with electricity or just want to understand it. It's good for safety.
Uniqueness of the problem within Ohm's law. Compared to internet problems, there are simple plug-in equations with one recessor and no real word context. Steps that help tell the difference between it. Uses a realistic scenario, includes multiple components, and requires high levels of understanding and calculation. What was added to make it so unique? Real life conditions were created to make it more unique. For example, heating and limitations. It requires interpretation, connects to Ohm's law to make the stage. How it goes above and beyond. This is unique and goes above and beyond because this is what most high-tech professions need and uses. For instance, sonography, radiology, etc. This goes beyond simple solving. You must be able to read, understand, calculate, predict, and interpret. Then we have visuals for the problem of Ohm's law. The first image, I have two images. The first image, this image represents Ohm's law, showing that voltage, current, and the resistance are mathematically linked to by the formula. And then here's the second image with a graph, a line graph. This graph shows a linear relationship when the voltage increases and the current increases at a constant rate. This triangle helps solve for any variable. This visual supports the same pattern. Your problem uses increases voltage, raises current, and a data with a straight line.
Brand new Ohm's law problem. In a small microcontroller project, I'm powering an LED from a 3.3 voltage output pin. The LED's data sheet says it has a forward voltage of 2.1 volts at its recommended operating current of 15 mA. To avoid drawing too much current from the pin, I need to add a resuscitator in series with the LED. First, find the voltage of the resuscitator has to drop. 3.3 V is equal to 2.1 V, which is equal to 1.2. They convert the currents into amps. 15 mA is equal to 0.015 A. Using Ohm's law, R is equal to V over I. R is equal to 1.2 over 0.015, which is equal to 80 ohm. Double check by plugging it in back into the formula and confirm that the current comes out to 15 mA. The units also check out. The units V over A is equal to ohm also check out. And the value makes sense because LED resuscitators usually fall in the 50 to 130 ohm range. So overall, the correct resuscitator value is 80 ohm, and going through the full process ensures the LED and microcontroller pins stay safe and the circuit works the way it's supposed to.
Okay. Ohm's law, the motivation, development, and relevance. Part D, 4.1. The motivation for Ohm's law was that scientists needed a simple rule to relate voltage, current, and resistance in electrical circuits. The development was George Ohm tested wires using different voltages and found a linear relationship, making the circuit. The linear relationship being voltage equals current times resistance. This became the basic law describing how the current flows. The relevance of the law is any question involving voltage, current, resistance, or how one changes when another changes is based on Ohm's law. It's the foundation for analyzing and predicting circuit behavior.
I picked resisting current and voltage because it's the easiest to solve and also the most reliable. The numbers are small because it's easier to focus on. And to write an Ohm's law question, first you have to identify the knowns, current, voltage, and resistance. And the unknown quantity you need to find, then use the Ohm's law triangle or the formula to set up the correct equation and solve the unknown.